Let's do part A. So first, we will write the sequence using this sequence formula, that is an equals 4n minus 2, and n goes from 1, 2, 3, and so on. So first, I'm going to plug in n equal to 1 into this formula. So therefore, this becomes a1 equals 4 times of 1 minus 2. And this equals 4 times 1 is 4. 4 minus 2 equals 2. Now let's find A2 by plugging in n equal to 2 into the formula. So it becomes 4 times of 2 minus 2, and this equals 4 times 2 is 8. 8 minus 2 equals 6. We'll find two more numbers, or the two more terms. So A3 equals 4 times of 3 minus 2, and this gives 4 times 3 is 12. 12 minus 2 equals 10. We'll find one more term, that is A4. This is 4 times 4 minus 2 equals 4 times 4 is 16. 16 minus 2 equals 14. So let's write the sequence using the terms A1, A2, A3, A4. So the sequence is A1, A2, A3, A4, and so on. Let me replace the values of A1, which is 2, and A2 is 6, A3 is 10, and A4 is 14, and it just continues. Now we have to understand what kind of pattern is this. So keeping A1 equal to 2, we see that the 6 is obtained by adding 4 with the previous term. And similarly, this 10 is obtained by adding 4 with the previous term in the sequence, that is with the 6. And similarly, this 14 is obtained by adding 4 to the previous term, 10. So every time we see that to generate that term, we need to add 4 to the previous term. So therefore, we can write down the recursive definition as an equals a1, that is, sorry, it is not a1. We can write down this as an minus 1. An minus 1 represents the previous term for an. Plus, we have to add 4. And we will also indicate that a1 equals 2, and also we have to give the condition for n. So this formula or this recursive definition holds good only when n is from 2. So we see that n greater than or equal to 2. So this is the recursive definition of the given sequence. Let's do part B. So first, let's write down the first few terms of this sequence by plugging in n equals 1, 2, 3, and 4. So let me plug in n equal to 1. So therefore, it becomes a1 equals 1 plus minus 1 raised to the power of 1. And this gives 1. Negative 1 raised to the power of 1 is negative 1, and this gives 0. Now let's find the second term by plugging in n equal to 2. So it becomes a2 equals 1 plus negative 1 raised to the power of 2. And this gives 1. Negative 1 square, this is a positive 1. So it gives 1 plus 1 equals 2. And let's find the third term by plugging in n equal to 3. So therefore, this becomes 1 plus negative 1 raised to the power of 3. And negative 1 raised to the power of 3 is negative 1. So it becomes 0. Let's find the one more term, that is a4. And this equals 1 plus negative 1 raised to the power of 4. And this equals negative 1 raised to the power of 4 is positive 1, because if you raise negative 1 to the even power, it is always positive, and if you raise negative 1 to the odd power, it's always negative 1. So this gives 1 plus 1 equal to 2. So let's write down the terms of the sequence, that is the a1, a2, a3, a4, and so on. So let's put this a1, which is 0, and then 2, and 0, and then 2. So it continues like this. Let's understand the type of pattern over here. Considering that the first term is 0, we have first term is 0, and the next term is obtained by adding positive 2 to this one, and the next term is added by adding negative 2 from the previous term. And similarly, The next term in this sequence is obtained by adding positive 2 from the previous term. So we see this pattern, that is every time we are adding positive 2 as well as negative 2. So this pattern itself is changing every time we add these numbers. So we can write down this sequence as a recursive sequence in terms of an, and this equals, we add with the previous term, so we put an minus 1 plus we have to add or subtract the 2. So for that we utilize this negative 1 term, this raised to the power of n times of 2. Since we have to add positive 2 as or negative 2 according to the n, we put this as negative 1 raised to the power of 2. And we also give the requirement, that is a1 should be 0 and this n should be greater than or equal to 2, because this formula holds good only for n greater than or equal to 2. Uh, so this is basically the recursive definition of the given sequence. We can have this verified. Let's suppose that we find a5 using this formula. We put n equal to 5 here, and this becomes a sub n minus 1, which is 5 minus 1 equals 4 plus negative 1 raised to the power of, since n equal to 5, I put 5 here times 2. And this gives a4. We know that a4 is 2. So therefore this becomes 2 plus negative 1 raised to the power of 5. It's an odd power, so it is a negative 1 times of 2. So this basically gives positive times negative is negative. 2 minus 2 equals 0. In fact, we know that according to this pattern, the next number has to be 0 here. So this formula is good. And this is the recursive definition for the given sequence. Let's do part C. So first, let's find a1 by plugging in n equal to 1 into the given sequence formula. So a1 equals 1 times of 1 plus 1, and this gives 1 times of 1 plus 1 is 2. So we get 1 times of 2 is 2. And let's find a2 by plugging in n equal to 2. So therefore this becomes 2 times of 2 plus 1. 2 plus 1 inside the bracket is 3. So we get 2 times of 3 equals 6. Let's find a3 by plugging in n equal to 3. So we get 3 times of 3 plus 1. 3 plus 1 equals 4. So we get 3 times of 4, and this equals 12. And let's find one more term, that is a4 equals 4 times of 4 plus 1, and this gives 4 times of 4 plus 1 is 5. So 4 times of 5 is 20. So let's write down this as a sequence. The sequence is a1 comma a2 comma a3 comma a4, and it just continues. So a1 and a2 is 6, I'm sorry, 2 and 6. I put 2 6, and a3 is 12, and a4 is 20, and it just continues. Let's see the pattern over here. Considering the first term a1 equal to 2, the next term, that is the second term, is obtained by adding 4 with the previous term. And the third term, this is 12, is obtained by adding 6 with the previous term. And the fourth term, that is 20, is obtained by adding 8 with the previous term. That is 12 plus 8 gives 20. So now even this addition, we can see this as a pattern, because in the beginning we are adding 4, and consequently this addition sum, or the addition number, is getting increased by 2. And we also find a relation between this number, that is this 4 6 and 8. When you look at this a2, this a sub 2, when n equal to 2, this is 4, that is 4, we can see this as 2 times of 2. And when n equal to 3, we have to add 6, which means we have to do 3 times of 2. And when n equal to 4, we get 8, that is we have to add 8 with the previous term. So it is 4 times of 2. So every time we see that it's according to the sub a sub n, when n equal to 4, we just have to add the number as 4 times of that n. So we can now, using this concept, we can use the recursive definition, that is an equals a sub n minus 1 plus 2n. Here a1 should be 0 as well as sorry, we have to write the condition for n, and n should be once again greater than or equal to 2. I'm sorry, a1 has to be 2, it is not 0. We already determined this. A1 should be 2. So this is the recursive definition of the given sequence. Let's verify this. Let's say we want to find A5. We know that A5, according to this pattern, we have to add, if this is 8, we have to add 8 plus 2, which is 10. So 20 plus 10, we should get A5 equals 30. So let's verify that. We put A5, that is n equal to 5, into the recursive definition. I put n equal to 5, so therefore this becomes A sub n minus 1, that is 5 minus 1 is 4, plus 2 times of n is 5, so it becomes 2 times of 5. So this gives, we know that A4 is 20, so I plug in 20 plus 2 times of 5 is 10, and this gives 20 plus 10 equals 30. So it holds good, and this means this recursive definition of the sequence is correct.